Oh, hello everyone. Today we are going to discuss Bandgap voltage reference. So it is another type of circuit. Kabaliktaran lang kumbaga sa current reference. So kung ang current reference maghatag og fixed current, ang kining voltage reference is mohatag og fixed nga current amid sa variation sa temperature and supply voltage. So, bandgap voltage reference is mostly used in any analog IC circuit. So, I have here some simple block diagram sa bandgap reference. So, the bandgap reference has this output nga fixed voltage with the changing of temperature and supply. So, with respect kung i-change nimo ang temperature, fixed gapon na tong voltahe. Kung i-change nimo ang supply, fixed gapon na tong voltahe. So, as I mentioned earlier, bandgap voltage reference is used in analog IC circuits. For example, the LDO, the buck converter, and the boost converter. Also, it is used for the mixed signal circuits like ADC and DAC and other circuits as well that use fixed voltage for computation or comparison. And one of the standard variation that is used in industry that must pass the industry standard is usually at negative 40 degrees to 125 degrees, because we don't know that this circuit can be used in the refrigerator that is below 0 degrees, and also it can be used for mining industry or sa desert baka nga init kayo ang temperature. So this circuit must stand at this variation of temperature. Also, in industry standard, we use this bandgap reference, or we test this bandgap reference with the variation of 10% to 20% supply variation. Also, for example, we have this voltage that is used variation from 4.5 volts to 18 volts. For example, we have a fixed voltage reference of 1.5. So amidst this variation from 4.5 volts to 18 volts, we must have a 1.5 volts voltage reference. Definitely this bandgap voltage reference, or the voltage reference, because there are a lot of architecture of voltage reference. The basic voltage reference architecture is the bandgap. So usually kana fix ang voltage amidst this variation of supply. So as am I saying, kana ang conclusion, bandgap is a reference that is independent sa supply and temperature. So, as I'm saying, kato supply variation o temperature variation dapat dili siya dependent. So bahalang mag-vary na siya, fixed gyapon na tong voltahe. But in reality, there's no voltage that is fixed at varied temperature. So usually naatay voltage nga increase with respect sa temperature. And also, we have this voltage or current that is inversely proportional to temperature. So, kanang increasing with temperature, the voltage or the current increasing with temperature is what we call the PTAT, or proportional to absolute temperature. So, that is dependent in temperature. On the other hand, we have these devices that is inversely proportional to temperature, and that is what we call complementary to absolute temperature, or the CTAT. So, But what we need, as I'm saying, is a fixed voltage. Mo na ang voltage reference amid sa temperature. So, kung natay circuit nga fix ang voltage amid sa temperature and supply, then we called it a voltage reference. But sa akong gingon ganina, walay ingana nga circuit nga diretso ra nga fixed voltage. So what will unsa itong buhaton to generate this fixed voltage? So to generate this fixed voltage here, we must cancel this P-tat and C-tat nga characteristics sa device. So for example, So for example here, we have makasulat na ako. Let me write. So I have here sorry. So I have here, for example 0.5 volts ang atong P-tat, 0.5 volts to 1 volt. And for the C-tat, 1 volt ang pinakataas and minimum is 0.5. And the average is 0.75. That is for example. So what we do is to add them together. So we have a C-tat here and a P-tat here. So ang buhaton? So 0.5 natay 0.5. We have 0.5 here plus 1 is equal to 1.5, right? And 0.75 sa P-tat, 0.75 po sa C-tat, then 0.75 plus 0.75 is equal to 1.5. And here we have 1 plus 0.5, then we have 1.5. So what we have done is they just cancel. So kay gi-add man nato with the same scale nga ilahang value, so na-cancel out ang P-tat ug C-tat. So the result is a constant voltage. How about kung ingani? Kung any P-tat and any C-tat lang nga value, and definitely dili siya ga-cancel. So we have for example, we have 0.5 So what I have here is ko sulat dire. So 0.5 og 1, and that there is 0.6, and this is 0.5. Siguro 0.75 po 0.75 nga lower po dire, for example ana. So 0.5 kani 0.65 siguro na siya dira. Okay. Plus 0.65. So 0.5 plus 0.6 is equal to 1.1. And 0.5 plus 1 is 1.5. So 0.65 0.13. So ang nahitabo dili siya fixed voltage. So we cannot cancel the P-tat and C-tat nga characteristics sa kini nga device. So any P-tat and any C-tat would not have an output of a constant voltage, which is not our desired value. So our desired value is a constant voltage. So this will not work. So how would we implement that? So in mathematical way, we can write this kana para ma-scale up nato. For example, natay 0.6 dire para ma-cancel nato ni siya. For example, gamit ko color green there. For example, i-multiply nato ning C-tat para mo grow. Dako siya. And then, sorry i-assume na lang as straight ni. But, definitely, kay same man sila o ganing scale. Example, nabot na siya 1 diri, for example. So kay gi-scale man nato na siya, this would make p-tat and c-tat cancel. So, in mathematical way, we can represent it as alpha 1, i-multiply na to ang p-tat, o ang alpha 2 sa c-tat, which make it a constant voltage. So, this equation here is the basic foundation of bandgap voltage reference. Using this equation, we can implement this into a circuit. So, we can represent this in a block diagram. So, we have here ang p-tat multiplied by alpha 1, or ang multiplying factor, then c-tat multiplied by alpha 2, multiplying factor para ma-scale up, then add them together, then we can have voltage rep. Just make sure this alpha 1 and alpha 2 would scale up the 2, or just scale down the scale up or scale down kining a value that makes them cancel each other, so we can have an output of voltage reference. So, next topic, since na-discuss na to ang kaning basics sa bandgap voltage reference, then next topic or next lesson, we will discuss how to make a c-tat circuit. So, see you then.